Hi viewers, today we are going to learn about mechanical translational system and mechanical rotational system. Now let us see what are the symbols we are using in the mechanical translation system, that is terms used in mechanical translational system, and what are the terms used in mechanical rotational system. In translation system the terms used are x is for displacement, and velocity v, it is nothing but rate of change of displacement, that is dx by dt, and then acceleration, it is rate of change of velocity dv by dt, and in place of v dx by dt it becomes d square x by dt square. The same terms, and also next F is the applied force and Fm is the opposing force offered by mass, Fk opposing force offered by elasticity, and Fb opposing force offered by friction. M is the mass, K is the stiffness of spring, and B is the viscous friction. Okay. Uh, Remember carefully, in translational system here displacement is used, and while coming to mechanical rotational system we are going to use angular displacement represented by theta. Okay. Here velocity, here it is angular velocity. Here it is acceleration, here it is angular acceleration. In translational system, if it is F is the applied force, in rotational system T is the torque, applied torque. Okay. And here M mass, here J is the moment of inertia, and here B viscous friction, here also rotational friction, and K is the stiffness of spring. Okay, the same terms, but here M is the mass in kgs, and here J is the moment of inertia applied. Here the terms comes like Fm, Fb and Fk, and here the term comes like Tj, Tb and Tk. These are the terms used in mechanical rotational system. So let us see the how we are going to give the formula for this Fm, Fb, Fk. You know this, see, this is the mass represented like this, and this is the J, moment of inertia, represented like this. It is going to have the torque here and angular displacement. See, for mass M we are going to have force and displacement. F in mechanical translational system, T in mechanical rotational system, X in translational system, theta in rotational system. In the same way all the terms. Okay. So like you are going to have Fk, Fb. Okay. All these terms you are going to have. So now let us see the formulas. What is the formula used for? In translational system we are going to have the terms of Fm, Fb and Fk. So see, the formula for Fm is m into d square x by dt square, Fb is b into dx by dt, and Fk is kx. If we have two displacement, suppose there is a dash pot like this. So if you have the terms here x1 and here x2 like this, two displacements, then the formula is b d by dt of x1 minus x2. Okay. So like this. And for k, two displacements are there, then k into x1 minus x2. And same in rotational system, tj, tb, tk. tj, Fm. So here m d square x by dt square, here j d square theta by dt square. Fb, Tb, b d theta by dt. Here displacement, here angular displacement. Tk, Fk, kx, k theta. Same two angular displacements are there, then theta 1 minus theta 2 and k into theta 1 minus theta 2. This is these 6 formulas you should remember. Along with the two displacement if you have, you should write that also. And next, if you take the Laplace transform of m d square x by dt square, then it becomes m into s square into x of s. And for b dx by dt Laplace transform, it becomes b into s into x of s. And Laplace transform of kx, it becomes k into x of s. So this is the Laplace transform. If you take for this Laplace transform tj equals to j d square theta by dt square, Then if you take the Laplace transform for this, you are going to get j s square theta of s. If you take the Laplace transform for tb, then you are going to get b s into theta of s. If you take the Laplace transform for this, tk is equals to k theta, you are going to get k into theta of s. So now let us see one problem on mechanical translational system. How to solve the problem in mechanical translational system. I want to discuss one point. So what do you mean by a displacement? Displacement and distance, right? See with example, see if there is one point here, okay, and if you want to reach this point, this is source and this is destination, okay. So to reach this destination, you have so many paths. See, suppose this is one path, okay, and this is one path, right? This path is nothing but the distance and this path is nothing but the displacement. Displacement is nothing but the shortest distance, okay, shortest distance from initial point to the final point, and this displacement, it is going to have the direction, okay, that's why it is a vector quantity, okay, that no need to that point, okay. So displacement means shortest path between the source and the destination is nothing but a displacement. Distance means it can be in any direction, okay. So just I want to give the small introduction to displacement, that's all. Now let us see one problem. One problem on this mechanical translational system. Write the differential equations governing the mechanical system and determine the transfer function. So this is the problem given to us. So see here one mass m1 is there, m2 is there, f of t is applied at m2 and for m1 no f is there, right? So first what you have to do is, first step is to draw the free body diagram. First you have to draw the free body diagram for m1, then you have to draw the free body diagram for this m2. So for this m1, what is the free body diagram? See, m1, what are attached to m1? K1, B1, okay. So this is the displacement, leave it, B and K. See, displacement you represent. So what are there? F m1, okay, as usual for m1. This is for mathematical writing purpose, we are writing here. As usual, F m1, okay, F b1, F k1, FB and FK. Total how many terms you should write? 1, 2, 3, 4 and 5. Remember, in mechanical translation and mechanical rotational system, we are using the law called Newton's second law of motion. Newton's second law of motion. Newton's second law of motion, that is, whatever the forces are applied, the force applied is equals to the opposing force. Here we are applying the force of f of t. And which are the opposing forces for this m1? See here. For this m1, the opposing forces are fm1, fm1, fb, fk, fb1 and fk1. So for this, here no f of t. That's why we will write it as 0. See how I am going to write this equation. It is going to have, see, fm1 plus fm1 plus fb1 plus fb plus fk1 plus fk is equals to 0. Is equals to 0, as there is no f here, okay. So now start writing the formulas. What the formula for m1? What we learned for m? See, fm. What is the formula for fm? M into d square x by dt square. As it is m1, right? So in the problem itself he gave m1. So fm1 means m1. Sorry, where is the formulas? Right. So what is fm? m1 d square x1 by dt square. Here in the problem, the displacement, first displacement is x1. x1, okay. So in place of x, you should write it as x1. So m1 d square x1 by dt square plus what is b formula, fb formula? B, if you have two displacement, x1 minus x2. No, only one means x by dt. But see in our problem, see the problem here. So for B1, so it is going to have only one displacement. In this side there is no displacement. So here only one displacement. So write B1 dx1 by dt plus B. See this B, it is going to have two displacement, both x1 and x. But what to write, x1 minus x or x minus x1? See, we are taking m1, right? So m1, from m1 side first term is x1. Then comes x. So you should write x1 minus x as you see from the m1. So for m1 you are taking, right? So write d by dt of x1 minus x plus k. K formula is k into kx. If you have two displacements are there, you should write x1 minus x2. So in our problem for k we have two displacement, and for k1 we have only one displacement, x1. So that's why check whether you are writing for k1 or k. So if you write for k1, you will write like k1 x1, and for k if you write x1 minus x. So now take the Laplace transform for this equation. So what I told Laplace transform means, for a d square x1 by dt square, you should write m1 s square into x1 of s, b1 s into x1 of s plus bs into x1 of s minus x of s plus k1 x1 of s plus k into x1 of s minus x of s. So you need to take x1 of s is equals to common. You take x1 of s common here, x1 of s, x1 of s, x1 of s, this and this. So if you take all those common, you are going to write the terms here. And if you take x of s common, you write the x of s common terms and separate them. x1 of s is equals to x of s. Remember one point, the question is what he is asking to determine the transfer function. So what do you mean by the transfer function? Means output by input. Here output is x and input is force f of t. If you take the Laplace transform, output is x of s and input is f of s. So that means you should determine x of s by f of s is the last conclusion you should give. X of s by f of s. So first we got this. So from this we got, leave it up to here, you leave it. According that we can write here also. Okay. So up to right you can write here, up to here. Then again free body diagram of M2. If you take the M2, what are attached to M2? Same. Here you should write FM2 as usual. Then FK, FB, FB2 and FM2. So how many terms? 1, 2, 3, 4 terms. So I wrote 1, 2, 3, 4 terms along with force F of t. Here the direction of force is like this and all these are the opposing forces along with displacement x. So as here f of t is there, see how we are going to write the equation. Here you should write the equation as f of t is equals to fm2 plus fb2 plus fb plus fk is equals to f of t. So what is m? m2 d square x by dt square. Okay, next b2 dx by dt. fb d by dt of, see for b2 only one displacement x, but for b two displacement are there, but now we are writing for m2, no? So you should write x minus x1, and for k you should write x minus x1 into f of t you should write. And then so you write the equations, all these equations. Now take the Laplace transform of this equation. So if you take the Laplace transform of this equation, what you are going to get? m2 s square into x of s, b2 s into x of s plus b s into x of s minus x1 of s plus k into x of s minus x1 of s is equals to, here k into x of s minus x1 of s is equals to f of s. So here take common x of s common terms and x1 of s common terms is equals to f of s. So see, listen, what to substitute here? Our main point is to get x of s by f of s. So means in the previous problem, that previous means what we drawn here, x1 of s is equals to, see, x1 of s is there, x of s is there. Here also for m2 we got x1 of s and x of s. So what to substitute here means, in place of x1 of s, if you substitute total equation in terms of x of s, that means, see here, if you make x1 of s is equals to this total, that is x of s into bs plus k by this term. So now you have x1 of s from this first m1 equation, right? So if this x1 of s is substituted in this equation, then you are going to have total equation in terms of x of s, right? So our main conclusion is to draw output. What is transfer function? X of s by f of s. So that's why I told you to wait until what to write here, whether to write x of s is equals to or x1 of s is equals to, right? So now you take x of s common here, take the LCM here, and you are going to write this, okay? So after, see here, when you are substituting here, already you have bs plus k, and this x of s, x1 of s equal to x of s into 1 bs plus k is there. So both it become square. So then the conclusion is x of s by f of s. Here cross multiplication is there. Okay, f of s means this, no? So that's why it went to numerator and this term came to denominator. So this is the total transfer function for that problem. Thank you.